Okay, guys, so let's start. So yesterday we have discussed about IPsec message exchange. Okay, so in that we have discussed, let's consider if this is initiator and if this is responder. So first message. So if this is the first message, so first message is about what? Essays. Initiator, SPI we discussed, and we discussed responder, SPI there. Okay, in essays with what concept will be there? Haggle, right? Second message is same, which is from the responder side. Third and fourth is about Diffie-Hellman. Fifth and sixth about authentication and identification here. And but fifth packet onwards, all the packets would be encrypted here. Then seventh and eighth packet is about ESP. Okay, here again we can exchange. We have to exchange what? Which encryption and hashing algorithm we are going to be using. This is also into which format? Encrypted format here. And then finally we have acknowledgement. So this is all about encrypted. Okay. So today practically we have to do the practical for the same. Okay. So EVNG you can use it. Let me start. CDP flex Okay, no problem. We'll go with this. Santosh, it's already uploaded on the drive. It's already there on the drive. Okay, guys. So now, so see, first of all, this is about 11.1, and this is about again 11.2. Just one second. Where is that? One more lab was there actually. So let me check it out again. Let's get GRE. Actually, I can read to no, that is not. Okay. Now see, here I'll configure as a chem policy. So one is the first one, which is about encryption. I'll use 3 dash hash. I'll use MD5 group 2 authentication method would be pre-shared and next. Okay. And lifetime, that would be default 86400 Okay. So this is a lifetime which I'm going to be used here. And this is the one. Second policy. Then third, we will configure here 4 policies there. Okay, so it means how many essays would be there? 4 essays. So this is 2, and this is, let's consider dash. One small change is equal to new topology, right? So this is about 3. Here I can use AES and I can use here SHA. And into this, again, one small change. So this is a 4, and this is, let's consider SHA. Okay, I can use another group, which is, let's consider. Okay, so now we have to call this as, and this would be on a VPN. So this is which VPN actually? This is my policy-based VPN. This VPN is all about which one? Policy-based VPN. Okay. So this is policy-based VPN. Okay. In between, if you want to use ISP, you can. Just you have to make sure reachability must be there. That's it. Okay. Now, so first of all, let me configure this on this device. First of all, basic reachability, we have to check it out. Okay. Along with this, just let me start in the capture here. This. So this is, I'll configure it as a site A. Okay, the host name is site A. Interface 0/0. IP address is 11.1.1.1/24. No shut. Interface loopback 0. IP address 1.1.1.1/24. And then IP do 11.1.1.2. Okay. Now, next is second outer. Kindly shut the door. Shut the door. Now, the next is here. Again, which interface? 0/0. So just let it be start. Host name is site B. Now, interface 0/0. IP address 11.1.1.2/24. Okay. Interface loopback 0. IP address 2.2.2.2. These are the LANs. Okay. IP route. All clear. I have just configured the IP addresses. That's it. Show IP interface. Great. 11.2 and test this. So first of all, now let's check the reachability. First of all, from site A to site B, ping with 11.1.1.2 reachability is there. So we have to make sure. Okay. So let's consider in between if you're using ISP. So then you have to make sure. Okay. So what should be there? The first condition is reachability must be there between the public IPs. Now try to ping between LANs here. So we have reachability, but as you can see in the Wireshark 1.1 and 2.2, we have its reachability is there and ICMP is going on, but you can see everything into which text here? Clear text here. Okay. So now we have to configure a VPN. Okay. So now out of this guys, on the other side, I'll configure this one, only single one. Okay. So let's start with the configuration here. So first configuration on, so this would be my initiator. I'll configure site A as an initiator and site B as a responder here. Okay. Now, so just see, okay, the command. The first command is crypto ISACAM policy. Question mark. This is the list of the number for the policies here. Okay, this is the kind of priority here. So I'm just going with the which one? Okay, in sequence we will configure four. First thing we have to configure as per Haggle algo. First of all, H means hashing, and I'll go with the which one? Undefined. Authentication. Next is what? Authentication, and I'm going to be use which one? Pre-share. Okay. Second is group. I'll use which one? The second one. Okay. Then encryption. First I'll use which one? 3 dash lifetime minimum 1 minute, maximum 24 hours here. So default one we will use it, so no need to configure anything. So how many which policy we have configured? The first one. Second is crypto ISACAM policy 2. Encryption. As per this only I'll configure this is dash. Then we have hashing about MD5, group 2, authentication, ratio. Crypto ISACAM policy 3. Encryption, AES, hashing, SHA, group 2, authentication, pre-share. Crypto ISACAM policy 4. Encryption, 3 dash, hashing, hash is about SHA 256. Then we have group 5 here. Okay. Authentication, pre-share. That is done. Okay. So show crypto ISACAM policy. So how many policies we have configured? 4. Priority 1, priority 2, 3, and 4. Clear? So what is the command here? So you just note down the command. Okay. So for the one, I'll show you crypto ISACAM policy 10. CAM policy 10. Encryption 3 dash hashing MD5 group 2 and authentication pre-share and etc. So this is, you can see, this is configuration 1. Okay. First configuration, or you can say this is kind of message 1. Which message we have configured? Message 1. So same thing we have to configure on the other side. Okay, that we will do it later. So, but this would be the which message? Message number 2. So this would be which one? Message number 2. Just make a note. All done? So message third and fourth would be automatically, because now here we have defined already which group of Diffie Hellman we are going to be using and which group of Diffie Hellman here. So then third, and so this is the manual one, and then third and fourth message is all about Diffie Hellman, and which is automatic. Diffie Hellman is automatic. Okay, so we don't have any configuration because we have already defined which group of the Diffie Hellman we are going to be using. Okay, just make a note, because configuration wise it has so many commands. So just try to understand which command where we need it and why we need it here.
So for all four, we need to use the different policies.
Sorry, for all
four policies we are using. So for policy number, we need to use different.
Yes, that should be different. Okay, right now, just for example, I have mentioned one, but how many I have configured? Four. So if you know one, how to configure it, you can configure multiple of them, right? This is done. Clear? Next. So this is message number. This is the message third, and this is message which one? This is about fourth. Okay. Now, next is message number fifth. We have not configured message 2. We'll configure it later, because first I'll configure all like everything on the site A. Message 4, that is all about authentication. So now means you have to mention authentication key. Earlier we have defined what is authentication method. Which method is there? The method we are using pre-shared. But have we defined any kind of in this, have we defined any kind of keys? No. So now we have to define authentication method. So which is about message number 5th here. Okay. So the command is, first, let me just write down crypto as a camp key. Cisco address. Cisco is the key, and I'm going to be shared with whom? Who's my another side? 15.1.1.1. Sorry, not 15. I think 11 I'm using. 11.1.1.2. What is that? 11.1.1. That's it. So this is key number what? This is key here. And or you can say this is message number 5th, which is on the side A. Same thing we have to define on side B, but this time we have to make a small change into the and key will remain same. So this is message 5th and this is message 6th. Kindly make a note. So this is, you can say we are defining here authentication key. What we are defining here? Authentication key.
So this is a kind of gateway we are defining here.
Not gateway. This is just an key with which whom I'm going to be shared. Okay. This is not a gateway. Okay, right now let's consider right now. Okay, I'm using a simple topology here. So let's consider if you have an ISP, for example, in between, this is, let's consider, this is site A and this is site B, and in between, if you have ISP. So in the training domain, we have to use what? Router only, right? So let's consider here, I'm using 11.1. Here I'm using 11.2. Here I'm using 15.1. And here I'm using 15.2. So what would be the command here? The command would be, instead of 11.2, I have to mention what? 15.1.1.2. But 15.1.2 is not my gateway. Actually, who's my gateway? 11.2 is my gateway. So this is not a gateway. So this is the destination, okay, or end point of the tunnel where we are going to be exchanging the keys. Okay. So this is clear. After this, fifth and sixth message is done. Seventh message. Seventh message is all about ESP. Which is that all about? ESP. For this, the command is crypto IPsec. Earlier, I was using ISACAM. In the phase one, whatever the configuration will be there, that will be with the which keyword? ISACAM. But now, in the second phase, configuration would be with which word? IPsec. So crypto IPsec transform set. We have to configure one transform set, name of the set, that is just a random name. You can, let's say I have mentioned the T set. It can be in a CCI, it could be ASA, it could be Amit or whatever. So this is just a random name. After that, just see, I'll use the command. So see, this is crypto IPsec transform set. What is the name of the set here? T set. So now you have to decide it, which protocol do you want to use it? Are you going to be use AH or ESP? So we have two options, AH and ESP. I'm going to be use ESP. In ESP, how many methods we have? Two. One is encryption and second is hashing. So for encryption, I'll use AES. Encryption, I'll use which one? AES. And for second is, this is encryption. What about hashing? I'm going to be use MD5. So ESP, this is encryption and this is what? Hashing. And just clear. So this is the copy. And now let me paste it. Okay. Same command, the same method should be on the another side. Because obviously this is kind of haggle. This is not exactly haggle, but at least like what we are defining here, which encryption and hashing algorithm I'm going to be using the phase 2 here. So that must be same on the another side. So this is about what we are defining here. We are defining encryption plus hashing. So this is your message 7th, and this is your message. That's it. This is the last command of your IPsec. 9th message is all about automatically, which is about acknowledgement. So now same things we need to configure on the another end. So this IPsec word is all about which phase here. If I'm using crypto IPsec, about phase 2, and if I'm using crypto ISACAM, which is about phase 1. So you have to just make sure of these things. Okay. And this is name of the transform set. Okay. So because we need to call this transform set somewhere now, and then what we have to call it? We have to call this transform set with its name. And what is the name of the transform set? T set. Okay. So up to here, I hope this is clear. So now let's get back to the side B. And on the side B, again, we need to configure.
So in future, if we change this like many policies or in the first tutor, then we need to change in destination.
Both, because things must be same on the both, not automatic.
But then address will be
Crypto ISACAM policy. One, I'm going to be use it. So which hashing algorithm we are using? Hash, MD5, authentication, pre-shared, encryption, 3 dash, and which group? 3 dash, and group 2. That's it. Okay, I have configured how many? 1 only. So this is the first thing. Now, after that, I need to configure key. Crypto as a camp key. What is the key? Cisco address 11.1.1. Crypto IPsec transform set T set here. In T set we have configured AES. So ESP, AES, and then ESP. Side we also configured. Okay, so up to here we have configured it on both the sides. Clear or not? Any doubt, any questions into this? Okay, so the configuration is very simple. It's not a complicated concept. This is just like crypto as a camp policy 10 encryption 3- hashing MD5 group 2 authentication pre-share crypto as a camp. Then about key. What is the key? Cisco address is 11.1.1.2 crypto IPsec transform set name is what name could be anything. I'm just using this one 3- and ESP. Let's consider MD5. That's it. So this is the configuration. So this is ditto configuration should be on the another side. Okay. Just one small change here. Instead of 11.2, this time it would be 11. Okay, up to here, I hope this is clear. This is we have just configured IPsec. So now on a router. So what I'm talking about in this router, there is a, let's consider this interface is which one? Z0. Might be one of the interfaces connected on the some other network. One is connected with some another network, then another network here. So this is another router here. This is another router here. This is another router over here. Okay. So what is the concept now? Might be, and this side I'm using a different tunnel, and this side I'm using something different tunnel. And now from here, I have configured one different tunnel here. So now I have to define whatever the concept I'm just defined it right now. So is this for the first, which now first of all, you have to configure the configuration, which is we have configured now. The first thing after this, you have to define interesting traffic. I'm not using a route-based VPN. The route-based VPN that is based on the routing. We can configure the default route here. But here I'm talking about the interesting traffic. The interesting traffic means which traffic has to pass through the VPN. The traffic has to pass through the VPN. Just note it down. What is the meaning of interesting traffic? Because in the futures, again and again, I'll use the term as a interesting traffic here. So what is the interesting traffic? As you know, we need ACL for that. So just first mention it. What is the meaning? What is the interesting traffic? So interesting traffic means, or the traffic has to pass through the VPN. It will take hardly 3 to 4 seconds. Okay. This is clear. Now, right now on this router, I have created in a loopback. I have created one loopback itself. And this loopback, let's, for example, this is my 12.1. 12.1, I'm talking about this interface, which is toward this router. This is something, let's consider 13.1. And this is considered here, I'm using something 14.1. So this is my loopback, which is I'm using as a 1.1.1.1. And here, which loopback we have? We have loopback as a 2.2.2.2. Agree with this or not? Yes, guys. Agree with this? So now, what is the concept here? We have to define interesting traffic. Okay, this is not a route-based concept, and as we have discussed earlier, in this concept, what would be needed? ACL. Okay, so the ACL we have to define what would be the source IP. So what would be my source IP? This network, destination IP, 2.2.0 network. It is after that define the protocol. Do you want to use IP or do you want to use any TCP specific or UDP specific or what you want to use? So I'll use which one? I'll use IP. IP means clear. So I have to configure one ACL. This would be my ACL where this ACL I have to mention on the this side. And same ACL would be needed on this side. Just what I need to change it. Source would be clear or not? Okay, shall I start? So now first, let me get into the site A. Site A. Access list 101, let's say 101. 101, I'm using extended one. The reason I have to mention source IP and along with that, destination IP. Permit IP. Permit what? IP. Source is what? 1.1.1.0. Okay. Wildcard mask. Destination is 2.2.0. Because I'm using ACL and ACL always use what? Wildcard. ACL has been defined. Now same is now on the other side again we need to define the ACL. Access list 101 permit IP who's the source 2.2 and who's the destination defined or not. So this is the ACL which we have. So this is for the site B and this is for the site A. On the site A, this one should be and this one should be. Is this clear or not? Noted down. So this is about what? Interesting traffic. Okay, clear? Now, after this, we have to define the crypto map now. What we have to define here? Crypto map. What is the meaning of the crypto map? The crypto map is kind of one mapping here. That is kind of what? As with the name itself, as we can now. Just one second. Now see. So till now, we have defined phase one. In phase one, we have defined Hagel. Okay. After that, we have defined authentication. Done. Same here in the phase one, we have defined Hagel, and then we have defined authentication. Let's consider Hagel is also same, authentication is also same. Phase one is up, phase two. In the phase two, I have defined ESP. In ESP, I have defined encryption and hashing, which is about MD5. Same, I have defined ESP on this, and I have defined here, let's consider dash or whatever, and this is MD5. Clear? So this is the protocol. So you can say this is the algorithm which I'm going to be used to encrypt or hash the actual data. Because phase two is all about what? Phase two is all about actual data. This is known as which we call it as a data tunnel also. Okay, or IPsec tunnel also. Clear? So this is the algorithm what I'm going to be use to encrypt the data. Next question. Okay, Amit. Which data? For that, I have defined what? This is the question, how you are going to be encrypt and how you're going to be secure it. This is fine with the help of ESP. And second, which data? ACL. In ACL, we have defined source and destination. Now we have to define next concept. We have to define here crypto map. What is this? Is mapping. Crypto mapping of what? Crypto mapping of this ESP I have defined inside what? Transform set and then ACL. So this transform set and ACL we have to integrate with each other. Because then only the traffic, if traffic would come, so then which algorithm we have to use it for the encryption? For that, who would help? Transform set. So now it's time for the last concept, which is crypto map here. So I have to define a crypto map. Okay, crypto map, crypto IMAP. This is just a, sorry, crypto map, map. The name is IMAP here, the question mark. Then I have to define a sequence. That could be anything that between the decimal, let's say I'm using 10, IPsec and ISEC. So this is the combination of what? Two, because IPsec is about which phase? Phase two. ISEC is about kind of what? Phase. The moment I have defined the crypto mapping here, one note is there. This new crypto map will remain disabled. It will remain disabled until a peer and a valid access list have been configured. So what are the two important things here which we have to configure? The one is peer, okay, and second is valid access list. So what is my access list? 101. And who's the peer? 11.2. Peer means endpoint of the tunnel. Endpoint of the tunnel here. In this diagram, so this is directly connected, but if I'll take you here, so what is the endpoint of the tunnel here? Is this 11.2 or 15.2? Which is the endpoint? 15.2. So who would be my peer from here? So my peer would be 15.2. And from here, who would be my peer? 15. Sorry, not 15.1, 11. Clear or not? So in this topology now, I have to define this. So first of all, let's, peer is asking, what it's asking? Peer. So command is set peer. Who's the peer? 11.1.1.2. Because right now I'm doing the configuration of which site? Site A here. So who's my peer? 11.2. Match address 101. This is I have mapped what? My ACL, and the last is set transform set T set. So how many things I have to define? 3 things inside the crypto map. So I'll just mention here. So I just need to define crypto map, name is IMAP, number could be anything, and I'm using here IPsec and ISA. So first define the set peer 11.1.1.2 set transform set. What is the name? T set I'm using, and then match address 1.0. So this is a crypto map, and this is a crypto map. So just on the another side, one small change, need to change the peers. Okay, so this concept is known as mapping, crypto mapping. Yes. Match address 1.1 ACL. This is what we are doing the configuration of. We have attached ACL. The first is peer, second is transform set, and third is ACL. And what are the must thing here? Because they have mentioned which is must, this is must, and this is must. So until unless you will not define these two things, your crypto map will remain disabled. Okay. Match address. This is 1.1. This is my ACL here. This is the full command here. Match address 1.1. Because what ACL you have defined? 1.1 only. So if it depends, this is not, this is always should be 1.1. If you have defined 1.2, you have to call it 1.2 here. Okay. Now the last step is, what is this is a crypto map I have defined. What is the name of my crypto map? IMAP here. Now you have to get in to the interface and call your crypto map. That's it. Call it on interface, because multiple interfaces are there. So on which interface you want to use it, that you have to define. Is this clear? Okay. Now, so this is the last concept is pending here. So now interface, just you have to make sure which interface 0/0 crypto map name is IMAP here, and just one message is there. What is that? ISA campaign. So it means configuration is till now everything has been perfect. Let's see. Sorry, interface 0/0 crypto map. What is the name? Okay, I haven't defined any crypto map here. So this is last configuration is only accesses. So let me define a crypto map first. Crypto map name is IMAP here 10. IMAP 10, and I'm going to be using IPsec as a camp. Who's peer? Sorry, set peer 11.1.1.1 match address 101 set transform set. What is the name? T set. Interface 0/0 crypto map name is click as the campus on. Now, so till now we have just configured the configurations and everything is fine. So now we have to verify. Okay. So the packets is getting exchanged or not. Okay, and exchanged packets are like encrypted or not. So we have a command. The command is show crypto IPsec SA. And this you will get the details. So what are the packets are encrypted and which is not encrypted here. Okay, but right now, can you see the number is what? 00 here. So what we have to do it, this VPN is your on-demand VPN. The policy-based VPN is your what? That is on-demand VPN. Till now, your VPN has not been configured. We have just configured the configuration. Okay. And if you want to ping a between 11.1 to 11.2, let's consider ping between 11.1.1.1. So this is 2. This ping is between what? This is site A. I'm just pinging what with what? 11.2. And as you can see the Wireshark here. So source is 11.1 and destination is what? 11.2. But it doesn't mean that my now tunnel is up. No. Because tunnel we have configured for what? Tunnel I have configured between the plans. What is my interesting traffic? So from here, my interesting traffic is source IP would be 1.1 and destination IP should be 2.2. But right now I'm trying to ping what right now the ping is happening to 11.2. So this is my destination IP and what is my source IP? 11.1. So it's not matching with this. Now let's consider I'll ping to 11.2 from 1.1 here. So I'll ping to home. I'll ping to 11.1.1.2 as a source of 1.1.1. I will able to ping, but show crypto IPsec SA. If you can check it, it counts as yes. Okay, the reason is because we have now, and here also can see there's just a ICMP echo. There is a no ISACAM. The reason still because here, what is the when I'm just doing a I have pinged now 11.1.1.2 as a source of what? 1. Ping with what? 11.1.1.2 as a source of 1.1.1. So still, what is my source IP here? My source IP is okay 1.1.1. Destination IP is what is that? 11.1.1.2. But what is my ACL? In ACL, I have defined the source IP should be 11.1.1. Sorry, that should be 1.1.1 and destination IP again must be 2.2. So interesting traffic is not there. If you would try to ping, this is okay if you are trying to ping with 2.2.2.2. So this time the source IP would be 11.1.1.1 and destination IP would be. So again, it's not matching. Now again, you can try here. Ping with what? And still. So the reason interesting traffic has not been generated yet. Okay, so this is on-demand VPN here. Which VPN? On-demand. So you have to generate, if you want to check the logs and everything, so you have to generate a interesting traffic. So let's generate an interesting traffic from here. So ping with 2.2.2.2 as a source of 1.1.1. Able to ping? Show crypto IPsec SA. Head count has been increased or not? Okay, and now you can check it out here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And after that, these are the ESP. So as you can see, everything is encrypted. So is this your telnet traffic, SSH traffic? No idea. I'll just go back to my site B. This is my site B. And let me configure here telnet username, admin, password, admin here. my username, CCI password, CCI. Okay, line VTY 024, login, local, transport input, or I have configured telnet on site. Which site? Site B. So from site A, try to telnet. Just telnet with 2.2.2. Will it take any source here? Because it's always from the physical, and just now go with this is telnet. I have done the telnet. Now you can see CCI and now CCI. So we are at which site? Site B. And if you would check it here, so this is telnet, SYN plus ACK, and SYN. So this is about telnet data here. This is not encrypted. Because what is my source? My source is 11.1. The source is not loopback, because with the loopback you cannot telnet there. Okay. So, and if I'll ping with 2.2.2.2 as a source of 1.1.1 here. So I have pinged right now. So into this, you can see what is the packet here, ESP. So now again, it's not going to be exchanged those 9 messages for the next 24 hours there. Okay, because this is ESP. Okay, and these are just encrypted, but no idea about that. What exactly the data? Could you just tell me, just with the help of the header, could you tell me okay, which traffic is it? No. Is this telnet? Is this SSH? Or is it ping? Or is it what exactly? No idea about that. Because everything is what? Encrypted. Encrypted with the help of the keying material. Keying material of what? With what we have, which we have exchanged in the phase 1. Clear? So right now everything is into which format here? Encrypted format here. Show crypto IPsec essay. So the packets has been increased. Let's consider ping with 2.2.2 as a source of 1.1.1.1 repeat 1000. How many packets I have generated? 1000 packets there. So it means earlier this head count was at 9. So now this should be 1009. Okay. Because this is interesting traffic, right? Clear? So what is the command you have to check it? Just note down the command, show crypto IPsec essay. So where you can check the count of encrypted packets. Now, show crypto. After that, we have so many commands into this. So you have to check in the 2 ways. Okay. Show crypto. Show crypto. So after that, there is a 2 possibilities. Just try to use it within the 2 ways. One is as a count, and second is as a IPsec. Okay, so IPsec is about which output most of time? Phase 2. And this is about which one? This information is about phase. Okay, so thus now I have used a command show crypto IPsec essay. Okay, details also you can mention in front of that. So you just enter it. So which information? The information where the packets are getting encrypted. Because where exactly the packets are getting encrypted into the phase 2. Okay, so this is the phase 2 information. Show crypto IPsec. Okay, question mark. I have checked it essay. Okay, then you can check it what exactly the transform set. Transform set is always into the phase 2. Which transform set I'm using it? I'm using a transform set as a T set. So this is one of the default transform set. What is the default transform set? E set with SHA. Okay. So just note down one more thing. In the transform set, we have two modes. Okay, one we have transport mode, and second we have which mode? Tunnel mode. In transform set, just note it down. Next in this one here. In the phase 2, the transform set has a two modes. One is transport mode itself, and second mode name is tunnel mode.
Transport is normal line.
Yes, transport mode has a two modes. Or sorry, transform set. Transform set has a two mode. One is transport mode, and second is tunnel mode. So you can see we have configured which one? T set, and in the T set by default, which mode is there? Tunnel mode. So by default, which mode is there always? Tunnel. In the upcoming classes, we will discuss what the difference between these modes, okay, how to configure transport mode, what exactly the use of the transport mode here. Because most of time, transport mode we use with the route-based VPN, not with the policy, okay? So you can see, so right now we are in the which mode here? Tunnel mode, because by default, which mode is there always? Tunnel mode is there. Okay. Show crypto IPsec, then question mark, just you can check it. SPI lookup here. So this is the SPI. Okay. Next we have, just use the question mark and just check it out, all this thing, which is the policy we are using, what are kind of security associations we have. SA security association guys, okay. What kind of security associations we have into this. So what is the lifetime and all, okay. So those kind of things we can check it out here. Because for the IPsec is about the which phase? Phase 2. What is the phase 2 timer, default timer? 3600 seconds, which is about the one. Show crypto AZCamp. Now AZCamp, I'm talking about the upper phase, question mark. What is the default information? What are the diagnose? What are the key? Which key are we using into that? So which key we are using? Cisco. Which key we have? Cisco. What is the host? 11.2. Okay. After the key, use another things. What are the SAs here? Okay. This is SA. So destination is 11.2. Source is 11.1. State is QM idle. Okay. Connection ID is this. And what is the status? Active. Clear crypto session. I'm going to be cleared the session now. I have cleared it. And if you would check it again, earlier it was active and now I have deleted. So what was the connection ID again? 1001. If you have to create it, like if you want to establish the connection again, ping with the or generated traffic, but like interesting traffic, because this is the on demand. I have generated show crypto AZCamp SA. Now this is another action connection. Last connection we have terminated. ID was for the last connection was 1, and now this is the another ID. So this is the entry of the last connection which we have deleted. So after almost 120 seconds, this entry automatically would be deleted from the table. Okay. After some time we would check it. This entry will be not. So only which entry will be there, which is active. Show crypto IPsec SA. Last time my count has reached to the 1009, but now it's again 4 because we have cleared the sessions. So let's consider if you want to make any changes in the configuration. So first you have to make the change. First you have to clear the you have to make the changes, and then you have to clear the session. Let's consider right now which in the transport mode. In the transport mode, which protocol I'm using? ESP. I have option for AH also or not. So what I'll do, show run section crypto on a site A. So you can see in the transform which protocol I'm using? ESP. As we can see here, which one I'm using here? We are using here ESP. So now I'm saying key instead of ESP, I'll use AH. But AH won't provide any encryption, it would provide only hashing. So only what? MD5. Name will remain same. Why I just want to keep the name remain same? The reason because this transform set I have already called inside the desktop. So that's the reason I'll not do any change. If I'll do the changes in the name of the transform set, I have to do the changes here also. So in the name, I'll not make any changes, but I'll make the changes into the protocol. So I'll copy the same command up to name, and then I'll use AH MD5. Just same command need to copy on your another side, because for another side also that must be same, right? But still, if you would now, I have made the changes. Ping with 2.2.2.2 as the source of. I'm able to ping, and if you can see here, still ESP is working. Even I have configured that, right? Repeat 100. These are the 100 messages. Clear or not? The reason? Because still connection has been established. Show crypto as a camp essay here. You can see the deleted, the last entries has been removed, and now you can see this is the last active session. Okay, so this would be active for how long? For the next 1 hour. Because phase 2 is valid for the how many hours? 1 hour. After every 1 hour, it would be renegotiated and then it would be established. Okay, so you have a one option, you just wait for the 1 hour, or second option is forcefully terminate the connection and then again initiate the connection here. So for that, the command is clear, crypto session. Note down how to terminate an IPsec session forcefully when it's needed. Clear? So I'll just enter here. We have cleared it. And now you can see entry we have deleted. But is there any active session right now? No. The reason because we haven't, because this is on-demand VPN. We haven't generated the traffic. So let's consider I have generated the traffic and now new connection would be there and that ID would be 1003, the next ID here. So if you would check it, so you can see. And this entry is deleted. After 2 minutes, it would be removed from the table. Okay, but this time I'm using AH. So AH means there won't be any encryption. As you can see right now, first 9 messages, 1, 2, 3, 4, 5, 6, 7, 8, and 9 here. And after that, I can see the messages. So this is what you can see authentication header. And inside that, I can see the data as well. So I can see here, this is about ICMP. But then you can see earlier with ESP, we were not able to check exactly. We were not able to see because that time encryption was happening. And now with AH, there is a no encryption. So this is clear or not? So this is 1.1.1 and 2.2 is my inner, this is my inner header, and this is my actual source and destination. But 11.1 and 11.2, these are the endpoints. Okay. Or you can see the peers. Okay. But let's consider in between if you have ISP, as for this topology, this one, as for this topology, what would be there actually? Then it would be 15.2. So here in the destination, it would be 15 dot. Okay, this is my outer header and this is my inner header. So this is the actual traffic and this is the endpoints of the VPN. Okay, in between we are using what? Authentication. But when I'm using ESP where everything is encrypted, even I'm not able to see who's the actual source. I can just see only what? Endpoints of the VPN. I cannot see exactly who's the source, who's the destination, what is the traffic? No idea because everything has been encrypted. So then if you would check it again, show crypto as a CAM. So this is essay we have seen it. This is, I hope this is clear. The other things are also there. What is check it? What is the profile? There is a no profile because these profiles would come during the IKV2 and all. Then question mark policies. The upper four policies we have configured, right? You remember in the starting we have created the 4 proposal that was the ISACAM proposal only, ISACAM policies. You remember the command was crypto ISACAM policy 1, 2, 3, 4. So this is the same policy. So this is concept as a security association. Use the question mark, check the PO, okay, and just enter. Who's the peer? 11.2. Because right now I'm on site A and site A IP is 11.1, but who's my peer? 11.2, which we have defined inside the crypto map and all we have defined with the key as well. Okay, so what is the port? 500 because UDP as a camp UDP protocol 17 and port number 500 and this is the 11.1 and this is the phase 1 ID. This is a phase 1 because as a camp I'm using, so this information is about which phase? Phase 1. So what is the phase 1 ID? 11.1.1.2. So phase 1 ID is equal to your PO. Okay. Next question mark again. You can check the key. We have checked it profile and also just kind of profile is not here. That's it. These are the so these are the some inbuilt, okay, predefined policies we have of ISACAM. These are the some predefined. Let's consider if you want to check it out, okay, what you can do it. Even this configuration is also not needed. This is also not needed. Okay, and even this, yeah, that. Without this configuration also we can configure because there is so many default or predefined assays are there. So that is going to be same for the another product also. So they would negotiate, okay, based on the priority and then accordingly they would use it. Okay, but we have defined manually. So manual was what? For that as a CAM policy. So these are the manual. And if you would go with the as a CAM policy, sorry, default policies, these are the clear. So what is the task for the day? The task for the day is what? And just kindly try to add an ISP. Today I forgot to add the ISP in between. Okay, so you have to make this topology there. You have to configure the VPN on the both ends and you have to verify its output here. So what are the commands? Okay, so we have multiple commands for that, but overall you have to try to understand show crypto. And after that we have 2 options. So one we have option, the one option as a CAM, which is for what? Which is for the phase 1. And second we have for IP. So this is for the phase 2 and this is, and after this you can use the proper question mark. Context help will be there. Use the question mark and this is for the what? Phase. Clear? So this is the show command. And other commands you have already written or else on your drive. In your drive, there is a one folder with the name of docs. So there should be one text file, okay, with the name of IPsec on router. Okay, so all the commands you can use it from there. Okay, header explanation, I'll not start it right now. Okay, and you have to try it with the two concepts here. One is with ESP and one is with EH. Okay, so proper packet captures and everything you have to make it. So tomorrow I'll start with the packet explanation headers. One is ISAC, second is ESP, and then EH. So these three headers we would complete it. So tomorrow is Tuesday. No, today is Tuesday. Then Wednesday. Okay. Thursday, I don't think so. I'll be able to take a session because we have one college visit over here. So I'll be busy into that. Okay. So if you would be agree on that Friday or something, we can have a one extra session at something 11 o'clock if you are fine. And that will be totally online because it's my week off. If you want, so we can just have a one session on that, or else we have sufficient days in the upcoming weeks. That's fine. Okay. Because last week also we had 3 classes. So this week also we will have 3 classes on. Okay. So we'll see. Okay. So if it's possible, so we'll try to make a one session on this Friday or something. But that will be only online. Not at 8 o'clock. That we can discuss. We can have at some other time. Something like 9 o'clock, 10 o'clock, something like that. Okay. That we would discuss tomorrow. If everybody would be agree, then only we'll have. Because in this batch, there are so many guys, they are working professionals also. I don't know that timings would suit to them. Okay. So that is about tomorrow's concept. Let it be. Okay. So these are the things which you have to do it today. Okay. So I hope you have practiced of GRE, right? All the outputs, everything has come. And now this is the task for the day. Clear? Any doubt, any questions, anyone? Online guys? I
No,
hope
sir. Thank you, sir.
earlier we created one manual tunnel interface. Today, how many tunnel interfaces? Tunnel interface is not needed because today I'm not talking about any route-based VPN. This is the policy-based. Route-based VPN is equal to tunnel interfaces. Okay. Okay. Yes, other guys, anyone, any doubt, any questions? I hope it's clear to all. Yes, Ashwini, Deep, Jyoti, Hema, Vicky, Dinesh. I hope all clear.
Sir,
Yes.
this crypto map is used just to confirm the peer and to transform whether we are using AH or ESP. Is that correct, sir?
This is to mapping, as the name itself is saying crypto map. Okay. So mapping is what? Mapping between ACL and then transform set. So one is that task and another is to define the peer. Okay. Who's my peer? 1102 is the peer.
Got it.
Okay. So in case in crypto map, if you want to define your transform set, so then what exactly how it's going to be encrypted, that would be missing. And in case if you want define match address, so means what we are going to be encrypt, so that would be missing. Okay. So you have to call it inside the crypto map. And then finally, you have to call that crypto map on the interface. Okay.
Sir,
Yes, please.
in transform set, you told that we have 2 modes. By default, tunnel mode is enabled. What
Right.
does it do, sir? What effect?
As I just told you, once we will talk about the transport mode, that time we will discuss, not now. Okay. So during the transport mode only, and when we will discuss the transport mode, when we will talk about the route-based VPN. Okay, we have a separate class for this. Okay, where we will talk about transport mode, tunnel mode, and about SVTI. Okay, note now. Yes, any other doubt, any questions, anyone? All clear? Yes, Santosh, all clear?
Sir, where we define who is the initiator and who is the responder, that depends upon.
Traffic generator, from where you would generate the traffic. Okay, because this is the on-demand VPN here. So in case if you would generate the traffic from the site B first, ping, okay? So who would send the first ISACAM message? Site B. And if you're generating the traffic from site A, so who would send the first packet? Site A.
And where we define this main mode and quick mode.
This is no, we don't have to define it main mode. Main mode is equal to the configuration. Okay. So where we have to define the how many messages? 6 messages there. Okay. So where you will define the ISACAM policies, then keys. Okay. So this is the configuration of about main mode here. So for aggressive mode, we have a different keys, different commands we have. So when you would use another commands, which is for the aggressive mode, so then your router would configure which mode? Aggressive mode. If you have to configure EIGRP, which configuration you use? EIGRP configuration. If you have to configure OSPF, router, OSPF, router, EIGRP. Okay. So if you are using EIGRP, so means what you are doing it? EIGRP, if you're using OSPF, so it means which configuration you are doing it? OSPF. So this configuration, what we have discussed today. So if you are using this, so this mode is known as main mode here. So for aggressive mode, we have different set of commands. Is this clear, Srini, now?
Yeah.
Okay.
Sir,
Yes.
today we saw that lifetime minimum 60 seconds, right? If it is set to 60 seconds manually, phase 1 will happen every time the traffic is generated, right, sir? Every 1 minute.
Right.
So after 60 seconds, it will going to clear the session, sir.
Automatically it would clear the session. So then you have to generate the traffic because this is the
Okay.
on demand. Let's consider if after 1 minute your session would be terminated, and after that you have not generated any traffic automatically. Right. There is a possibility one is traffic is generating automatically or you are generating it manually. So until and unless that interesting traffic won't be generated, so your next connection ID will be not there. Okay.
Yes, sir, got it.
Now I'll save the configuration here only because tomorrow again this concept would be needed. Okay, because tomorrow we'll discuss about SPIs and all. Okay, and about the header. So this concept, I have just saved the configuration. So tomorrow we'll not configure it again. Okay, we'll just use the topology and then just start. So just guys practice this one today. Okay. So shall I close the meeting, guys? Online? All clear?
Yes, sir.
Okay.
Thank you.
Okay, then see you tomorrow. Bye-bye. Take care. Thank you.